Hello everyone, welcome to my third video lecture in this series of math and programming interview questions and solutions. Uh, let's dive into the problem and see what the problem statement is about. Okay, so we are given two arrays, which is nums1 and nums2. So what we need to find out is for every element x in nums1, we need to find next greatest element of x, which is this. So like I said, the next greatest element for x will be equal to y, where y is the first greater number to x's, right, in nums2, and here x belongs to nums1 and y belongs to nums2. For example, in this we have 4, which is occurring here, and the next greatest element is none, so in this case it would be -1. So that's why you have -1 here. You have -1 here, and for 1 occurs here, and the next greatest element is 3, and that's why you have 3 here. And for 2, 2 occurs at the end. There is of course no next greatest element to it, and therefore you have -1 here. So let's go ahead and let me walk you through some more examples before I write an algorithm for this problem. First example, I have nums1 as 3, 1, 4, and I have nums2 as 5, 4, 3, 2, 1, 6. So let's trace our solution to this example. So for for 3 in nums1 occurs here, and the next greater element is not 2, not 1, and 6, right? So your resulting array would be, so result equal to, for 3 you would have 6 here, let's see, for 1, so 1 occurs here and 6 is the immediate next greater element, so you would write 6 here. For 4 is occurring here, and 3 is not greater than 4, 2, not 1, and it's 6 for 4 as well. So what did you observe in this example? What we observed in this example is, let's say you have a sequence of decreasing numbers like 5, 4, 3, 2, 1 in this case, and you have a number that is greater than the first number in the sequence of decreasing numbers. Then it's going to be the solution for all of these numbers. So using this idea, we can use a stack to represent a sequence of decreasing number, and whenever you see an increasing number, then you know that that is the solution for all those sequence of decreasing numbers. And by the way, I decided to use Artweaver as Artweaver is very handy with my drawing tablet compared to Paint. Okay, now let's go forward and write pseudocode for this problem. Here I have to the left I have the pseudocode, and to the right I have an example that I want to trace my pseudocode against. So basically the first line says that I want to have a result array where I'll store all my results, and then I have a stack that I was talking about previously, and then I have a map, which you guys will know why I am using it for in a second. So the algorithm goes like this. I want to trace, okay, let's trace this algorithm against this example now. So I have let me use another. I have a stack S, and let's draw a stack, and I have a map M, and I have a result array, right? Okay, so for 0 to n minus 1 in nums2, right? So the first one is 9. So while stack is not empty, initially stack is empty, so we won't go into this while loop, and we will directly push 9 to the stack. Okay, for the next, now let's go to the next number. So 6. So 6 stack is not empty. Yes, it's not empty. And stack dot peak, which peak means the top element of stack, right? So here the top element is 9 right now. Is 9 less than 6? No, so we won't enter this while loop, and we'll just push 6 to stack. So the next element is 4. Stack is not empty, but the top element, which is 6, is less than 4. No, that's not true. So we'll just push 4 here. The next element is 1. Stack is not empty, and the top element, which is 4, less than 1. No, so we'll just push, um, we'll just execute this statement. So for all these elements, we did not enter the while loop, and we just executed this one statement, and just we pushed these 4 elements into the stack. Okay, now the element is 2. Stack is not empty, and what's the top element now? It's 1. 1 is less than 2. Yes, that is correct. So our while condition is satisfied, and we enter the while loop. And what we are doing in the while loop? We are popping the top element, which is 1 in this case, and we are adding it to a map. So it would be like this: 1, 2, and let's iterate the while loop again. So the top element is 4 right now. Stack is not empty. 4 less than 2? No. So we break the while loop and we push 2 here. Okay. And we go to the next element, which is 3. So stack is not empty, and what's the top element right now? 2. Is 2 less than 3? Yes. And so we go into the while loop, and we pop this from the stack and we add it to the map. 2, 3, and the while loop breaks in the next iteration, because we have 4 as the top element, and 4 is not less than 3. So we just push 3 here and go to the next element. So the next element is 7. So while stack is not empty, what's the top element right now? Which is it's 3. So 3 is less than 7. So we pop 3 and we add it to the map. 3, 7. Now in the next iteration, the top element is 4, and 4 is also less than 7. So we add 4 and 7 here. And in the next iteration, we pop it from here and we then add it here, right? So the next in the next iteration of the while loop, stack is not empty and the top element is 6. So is 6 less than 7? Yes. So we pop this, add it to the map. In the next iteration, the top element is 9. So stack is not empty, and 9 is not less than 7. So we terminate the while loop at this point and we just push 7 here and go to the next element. So 5 is the next element. So while stack is not empty, and what's the top element? It's 7. So 7 is not less than 5, and we just push 5. At this point, we have reached the end of the array, and the for loop terminates. So this for loop will terminate after reaching 5. Okay, so if you look at the result set, not the result set, but if you look at the map, we don't have values for 9, 5 and 7, right? And that is because 9 is occurring here, and do we have any element that is greater than 9 to the right of it? No, right? So that is why we did not add 9 to this map using this algorithm. Same thing goes with 7. 7 occurs here, and we don't have any element greater than 7 to its right, so we don't have a solution for 7. And of course 5 occurs here, and it's the last element, so it will not have any elements to the right of it. So for all these values, like we defined our function here, it should be -1 if y does not exist, right? So y does not exist for these 3 numbers, and we have to return the solution as -1, which we'll be doing in the next for loop. Okay, so for now we are here, we are iterating through nums1. So this is for nums1. So and we want to look up each value of nums1 in this map. Okay, so we want to look up for 9. So what get or default does here is, if there is a value, if there is a key for nums of I, it will return the value, but if there is not, it will return -1. Okay, so For 9 it's going to return -1, so the result of I equal to -1 for 9. And for 2 it's going to return 3, right? So we'll have 3 in the result for 2, and for 6 we'll have 7, right? And if you observe for these three values, this is what I was talking about earlier. When you have a decreasing sequence like 643 in this example, and you encounter a number that's greater than all three of them, which is 7 in this case, then you can blindly say that 7 is the solution for all these three numbers. This is one pattern that I could identify, which ultimately helped me reach to a solution for this problem. So that is it for this. Let's go much deeper and find out time and space complexities for this problem. Assume m is the length of nums1 array and n is the length of nums2 array. So what would be the space complexity here? Assuming that the result array is not a part of space complexity, the only space that we are using is for the map. And in the worst case, what would be the size of the map? It would be for example, if you take nums2, the max size of the map could be this length, which is n minus 1. The map will not include the last element because the last element solution is -1. So space complexity would be n minus 1, which is big of n. Okay, so let's look at time complexity now. To the right of the screencast, I have written down the main steps in the algorithm. So one common mistake made by beginners is they think that I have an outer loop here and I have a nested loop here, and loop is running through n items and the complexity is n square. That's not the case always. So for example, in this for loop, let's disregard this while loop for a moment, and if you see this, it's pushing which is doing a constant amount of work for n items, and the while loop is popping an element and adding it to map, right? So think about this. We have n elements in the array, and how many pops can it make? So popping an element from an array means adding it to the solution, right? So it can at most pop just once. So there will be, and it will not pop 5 at in any case, because 5, there will be no solution for 5, and the last element in the array will always have -1 as solution. So at most there will be n minus 1 pops, right? So for example, an example for n minus 1 pops case would be 1 2 3 4 5. So 1 will be added to an array. So if you trace the solution for this, you'll observe that there will be 5 pushes, and you will have 4 pops, right? So you will push 1, and then you'll push 2, and before pushing 2 you will pop 1 and add it to the map with 2 as its solution, and this will go on for even 2, and then 3 4 4 will be popped and 5 will be added as solution, but 5 will not be popped because there is no solution for it. So there will be 5 pushes and 4 pops. In similar case, if you generalize the solution for and analyze this loop, you will have at most n pushes, and you will have at most n minus 1 pops, right? And the next for loop will run m times, right? Assuming the length of nums1 is m, so it will run m times, so plus m, and this is equal to 2n minus 1 plus m, and this is in the order of, if you think m plus n, you are right, but this is actually n, because you can write this as big of m plus n, but if you read the problem statement, it is given that nums1 is a subset of nums2, right, which means that m, let me write it down here, m is always less than n, right? Therefore m plus n can be written as just n for bigger. So that is it for this lecture. If you have any questions, any suggestions, or any alternate better solutions, please post them down below in the comments, and I'll see you next time with a new lecture. Bye.